Welcome to the Cool Tools Show. I'm Mark Frauenfelder, Editor-in-Chief of Cool Tools, a website of tool recommendations written by our readers. You can find us at cool-tools.org. I'm joined by my co-host, Kevin Kelly, founder of Cool Tools. Hey, Kevin.
Hey, it's great to be here.
In each episode of the Cool Tools Show, Kevin and I talk to a guest about some of his or her favorite uncommon and uncommonly good tools they think others should know about. Dan Slaski is a product designer, Ironman triathlete, and blogger of all things digital manufacturing. By day, he tackles crazy engineering problems and puts machines in some of the world's harshest environments. By night, he plots to share STEM's awesomeness through nefarious activities like 3D printing ninja stars and 3D scanning Pez dispensers. That sounds really cool. How are you doing, Dan?
I am great. It's such a joy to talk to you both. I'm a huge fan of tools and love talking about them and love the show.
Well, we can't wait to hear what you have for us. Thanks for joining us.
Yeah. Why don't you start by telling us about Solidworks?
Yeah, so I am a professional product designer, and so it's an amazing job, and it's kind of like making it a professional job. So I kind of wanted to share that with people and kind of maybe help people figure out the path to get there if that's something that sounds cool to people. So SolidWorks basically is it's professional 3D modeling software. So I know you guys have talked a lot about some of the hobbyist versions, but this is a professional version.
Mm-hmm.
And it's by far the tool I use the most. So I probably use it 4 hours at least every day I'm at work for the past 16 years or so. And I've used it to design crazy assemblies with thousands of parts. And it's the functionality is next level from your home maker stuff. It really has a bunch of analysis tools, first of all, so you can do stress analysis and flow analysis and all that kind of stuff. And it really integrates with kind of the company's manufacturing cycle. So you can do drawings, you could do sheet metal, you can create bills of materials, exploded views. So it's kind of this whole, I mean, I could talk about it for hours, but it's this whole integrated system that basically allows me to be a one-person leverager of do the work of multiple people, or do what would used to take the job of multiple people as my own.
And so it sounds like in addition to being able to say draw the different parts in a kind of a 3D way, you're saying you can do some kind of engineering functions where you are testing whether or not there's any overlaps, or there's enough tolerances, or whether given the materials, it's going to be strong enough. Those kinds of things it'll also model as well?
Yeah, so it is called computer-aided design and computer-aided engineering. So the way it works is it has a lot of different add-in packages. So a lot of those will be add-ins. But yeah, you can run different load analysis on parts, and yeah, you can do all of that kind of stuff. Or with the sheet metal design, you can unfold the sheet metal and see. So it does. One thing I want to be clear though is it doesn't think for you. I think a lot of people think that you still have to think, but it certainly can leverage what a designer can do.
Dan, can you do and explain like I'm 5 definition for me for the term parametric modeling?
Basically, it's feature based, and so what that means is I can change parameters kind of on the fly, and the model that I'm working on will kind of scale in real time, particularly if I've designed it in a smart way. And so that makes it really cool because someone could come in and say, well, what would this look like if this was a little bit taller, or this was a little bit longer, and it will kind of stretch and skew, and all these things will happen, and your design intent should translate. So the holes will move, and all this kind of stuff will move as you would intend the design to do.
Cool.
And so where does because SolidWorks is fundamentally at the core kind of a 3D CAD program. Where does it fit into the landscape of CAD programs? There's at the low entry level there's like Tinkercad, and then there's Autodesk, AutoCAD, whatever this called now, Fusion. There's kind of a landscape, and I'm just maybe you can kind of place us in that landscape.
Sure. So there's one thing that I want to talk about is that it's not cheap, right? So there's certainly other ones that have come along that are much cheaper. But what's interesting about SolidWorks is historically they've owned a large market share of the design space. So I wanted to make people aware of it, because if you do want to become a designer, it's kind of important to get your foot in the door. So if someone came to me and said, hey, I and you could get student licenses as well. So if someone said, hey, I've trained myself and I know how to do this, that would be a person that would totally be someone that we could hire as an intern or something like that. But to answer your question, the landscape is definitely changing quite a bit. Like I think Fusion 360 has taken a lot of the marketplace, and there's one called Onshape that's also becoming more prevalent. So what made it popular was it was kind of the lowest end of the professionals, but now kind of the lower end ones are kind of creeping up on it. So in certain ways that's a good thing, but I just wanted to make people aware of this tool, and kind of as a way to get your foot in the door if you want to become a professional designer.
And is this the only 3D CAD program that you use, or do you use all of them for different functions, or is this sort of like your go-to right now?
It's my go-to. The organization that you work with, it kind of becomes entrenched, and the files don't necessarily share or play well from one to the other. So if you move a file from one CAD program to another, you kind of lose all of your design history and all of that intent that it's in the file, and it becomes very hard to change a package once you've organizationally implemented it.
So switching costs are high.
They are. So I don't even have a personal license of this, so I have to use other stuff kind of on my own when I want to do my own tinkering around the house.
And what do you use for that?
I've been using Onshape, which is quite similar to SolidWorks, so it's quite easy to learn. Oh, and an additional thing is that SolidWorks requires kind of a powerful computer to run as well, compared to a lot of these other cloud-based ones. So I do think the landscape's changing quite a bit, and is going to change even more over the next few years. But as I said, it's kind of so entrenched in the industry that you can certainly expect it to be around for a while.
But the one that you're using at home, is that a cloud-based one?
It is. Onshape is cloud-based, which is one thing that's really cool about it.
Do you recommend that for people who are maybe not so committed, or is it a little bit easier for the beginner?
It's very similar. I think it's actually made by people that left SolidWorks. I would say if there's bunches of free YouTube tutorials and all kinds of stuff. I've taught it at my work, and if you commit, I would say probably a solid weekend, I think you could be up and making some pretty decent models.
Okay,
that sounds cool.
And what is the cost of it? Did you mention that?
No, so it varies a lot. So I think the basic package is around $4,000, and
wow,
yeah, I know.
Okay.
And they also have kind of a subscription service where it's $1,000 roughly per year to get upgrades, and the files you can't open a 2020 file in 2019, for example. So there's definitely things about it that that are not ideal, and that I don't like. But I mean, the power of the tool is kind of so strong that you can start a business easily on your own just by owning a license of SolidWorks.
A business being designing for people.
Exactly. So if you look at it that way, it's a huge it's a low cost, but yes, for an individual, it's high.
Okay.
So
fair enough.
Yeah. What's next on your list?
Yeah. So the next one's a book. It's called Making It: Manufacturing Techniques for Product Designers. And kind of the high level tool that I actually wanted to share was kind of understanding manufacturing processes a little bit, because as a designer, myself included, we come out of college with a lot of perhaps technical knowledge, but very little practical knowledge. So kind of tying it into SolidWorks, you can make a part in SolidWorks that looks great, but is totally not manufacturable. And so there's these kind of a lot of rules of thumb and a lot of different kind of easy to learn things that are obvious once you realize them, that really make you able to design great parts that are affordable and that are manufacturable and that are scalable.
And so this book kind of goes into what those rules of thumbs might be, and the common sense, or the kind of the language or the grammar of manufacturing, so that you can learn that pretty quickly.
So this book's actually just like a super primer. So it's just kind of like a one-page description of what it is. And then my actual recommendation would be to just kind of Google. So a lot of the parts that I do are CNC milled, for example. So if you just were to Google CNC milling tips and tricks, or CNC milling cost cutting. You'll find people that have created web pages with kind of like, hey, here's 10 rules. Don't make a pocket with sharp corners, and don't do things like this, because that can't be machined. And so that would be kind of the next level. So the first level is just to understand what processes are even out there, and then whichever ones you decide to use, kind of go one level deeper than that.
So there really isn't kind of a complete text right now. It's just all spread through YouTube or Google.
Well, I did recommend another book called, I believe it's Trade Shop Machine Secrets. And so that one would be a great one, for example, if what you wanted to do was just understand like CNC milling. That would be one I would highly recommend for that. Mm-hmm. But kind of another pro tip is that there's all these different sites out there now where you can upload a CAD model. You can even do it directly from SolidWorks, and then it will tell you, we can't machine this part because the corners are too tight, or because the pockets are too deep and stuff like that. So you can kind of iteratively learn that way. Whereas if you just go to a traditional machine shop, they'll just come back with a high price, or they'll just tell you no quote, and you won't know what you did wrong that made it difficult for them to machine.
Yeah.
So the specialty sites where you're submitting a CAD program and they're giving you a response, are they doing that with a human in the loop, or is that just an AI algorithmic decision?
It is AI. I think sometimes sometimes I do this where I kind of stump the AI a little bit, or do stuff that's a little bit on the edge, and then it will go through a person. But if it lets you order it right away, it's through AI.
Yeah. Okay.
So yeah, I have that Making It book, and I do recommend it because it shows you the possibilities of different ways to make things. Sheet metal, turning, knurling, water jets, all the different kinds of things that help you like see kind of what's possible that you may not have realized. Thermoforming, all that kind of stuff opens up possibilities for you, as well as constraints.
Yeah, that's why I love design, because it's essentially a puzzle where each one of those processes has different pros and cons, right? And so you have to kind of try and utilize the different pros and cons of each one. Plastics, you can maybe make more aesthetic parts, but it might be higher volume, and it's this beautiful puzzle, and it's what makes it so fun.
Yeah, I agree.
So in the same kind of vein, you have another suggestion here, Snapmaker. To tell me about what that is.
Yeah, so I'm a avid fan of 3D printing. I've been using the technology for like 16 years since I went to college. And yeah, I know. So I went to Virginia Tech, and they had one of the first additive manufacturing courses in the country. And at the time, it was pretty much a novelty. And now I can't believe how far it's come as far as accessibility and ease of use. And so I had to recommend a 3D printer. And I get the question all the time, what 3D printer would you recommend? And the answer is it depends, right? It's kind of like, what bike would you recommend? Because there's different ones for different purposes, right? Do you want a mountain bike? Do you want a road bike? What's your budget? There's all these different things. There's kind of no one right one, and there's no perfect one. But I really like the Snapmaker a lot. I did a review of this one. And well, first of all, it's cool because it's a 3-in-1. So it's an FDM printer. It's a laser engraver.
What does that FDM? What does that mean?
Oh, that's fused deposition modeling. So that's the kind of 3D printing. They kind of call it the hot glue kind, where it extrudes the filament out of a hot end and then does it layer by layer. So that's that kind of technology. There's different.
That's the most generic, basic type, right?
There's the resin kind that have actually come down in cost. So like Formlabs and other companies have made those more accessible. But yeah, I would say 90+% of people that have them at home are using the FDM or FFM. Same thing. Yeah.
Right. So that's the first type. And then what's the second one?
So it's a 3D printer. It's also a laser engraver and a CNC carver. So it has different head attachments that you put onto it, right? Which makes a lot of sense, because it's basically just this gantry moving a head around, which is kind of how all three of them work.
So it's additive in terms of the 3D printing, but it's also carving and subtracting as well.
Bingo, yeah. So you can, that's exactly right. So You can make different parts, by exactly. So, and then combining them, or CNC carving and then lasering. So I made a cool ninja star as kind of a fun way to test all three processes. But yeah, so what's beautiful about this machine is that it does do all three, and so I think that's kind of cool, because I'm not sure people are as aware of like CNC carving or engraving. 3D printing kind of gets all the hype. And getting back to different processes and pros and cons, the other ones are awesome as well and can have super cool applications. So I really like this because I think it's a great primer. Like, I think this should be in every university and makerspace. It's robust, and it's just can kind of bring awareness to all three.
And what is its bed size? What's the largest thing that it can produce?
Yeah, so it's quite small, right? So it's like 5 inches by 5 inches by 5 inches. So, Mark, I know you like to 3D print, and as soon as you get into it, you kind of start wanting to get bigger and bigger parts. But I think this is just great to get people excited and to get people just kind of into it. I'm still amazed how many jobs I've been at, or how many universities or art spaces don't have these kind of machines, and they're so accessible. And at Tech Shop, for example, they would call the laser cutter the gateway drug, because it gets people so excited once they see what it can do.
And this Snapmaker had a laser cutter as part of one of its heads. Is that right?
It does, but similarly to its small bed size, it's pretty small. It's pretty low power, so it's more of an engraver than an actual cutter.
Etching stuff. Okay, yeah.
But they are coming out with a 2.0 that I think is a lot bigger. This was a Kickstarter project. It's a lot bigger, and I think it has a more powerful head. And I think to me, this validates that you can put 3 in 1, and it can actually be, it can actually work really well. It's actually not a huge sacrifice to any of them.
And the cost is $700.
Yeah, that's right.
How does that fit into, like, say, Mark, the 3D printer that you prefer? Is it about the same, or?
Let's see. Well, I have a Prusa, and it costs, I think, around $1,000, maybe a little bit less.
But I mean, if you wanted to get a printer of this size, you could probably get one on Amazon for $200, for example. So
just a printer.
Just a printer. But this one, again, it's really solidly built the way that they've done it. It has a nice touchscreen, and it has this nice kind of modular design that I think it would, again, make it very, very great for like maker spaces and stuff that you can kind of switch out. It has these linear rails that you could switch out. So it's just a well-designed, cool product. It's a cool tool.
Cool.
That looks good.
All right. Snapmaker. So the last one is 180 formula.
Yeah. So
I have no clue. Tell us about it.
So switching gears a little bit. So I do hang out at maker spaces a lot, and I am a triathlete, and I see a lot of people at maker spaces that maybe aren't eating the best and are a little bit sedentary. So I wanted to do a health and wellness related one. So the 180 formula is pretty simple. Basically, you take 180 and you subtract your age, and then you can add a little bit or a little less depending on your fitness. But basically, that's the heart rate that you should train at. Basically, try and staying at that or below that. And what happens is once you do that, and well, first of all, if you go out and actually do that, it will feel slow. Like you'll go out and runs and you'll feel like you're crawling. But after a while, your fitness starts to change, and over weeks or months, you'll see that at that same heart rate, you're going faster, you're going longer. All these adaptations start to occur. And the other thing that's great about it is I see people running and they go out for 20 or 30 minutes and they just look like they're going full tilt, right? And they're just they look like they're in such horrendous pain and that they're hating every minute of it. And so I think if you do this, it's actually pleasant. Like another way to think about it is called a conversational pace. So you're going out at a pace where you can actually have a conversation with the person next to you. And so it's just amazing what happens over time. Well, and you're burning fat as well, which is the other thing, which is, I think, a goal of a lot of people. But you start to enjoy it, and you start to explore your landscape, and you just start to see exercising in a completely different way.
So in general, it seems to be suggesting that when you do the subtraction, your age from 180,
Mhm.
that heart rate would tend to be lower than what most people might think that they should exercise at.
That's right.
Is
Yeah,
is that the idea?
exactly.
It's not higher; it's actually lower.
It's lower, right?
Okay, and so somehow by slowing down, so to speak, you are going to better your fitness or your exercise by slowing down.
Right. So you're using different energy systems. So you're using more of your fat burning energy system instead of your glycogen system, and
Mm-hmm.
which is, you have more fat stores, and so you can kind of go longer. And yeah, you're not in this. Most people go in this area that's between sprinting and between going slow. They're kind of going in this gray area, and so you're not getting the benefit of either. But if you just go kind of slow for longer, your heart gets stronger. And again, I'm an amateur triathlete, so take this for what it is. But I've just seen it do magical things for me, where you start running, and it's not it feels like you're going for a brisk hike, but you look down at your watch and you're cruising along, and you'll see side streets in your neighborhood that you haven't seen before, and you'll start saying, oh, I'm gonna jog to the store. It just has all these magical side effects but you have to be disciplined about it, because you do feel like you're going really slow for the first bit compared to probably what you're used to.
Yeah, well, I'm used to going slow, so
perfect.
Well, yeah. So I was wondering, like, what's the easiest, simplest way for someone to monitor their heart rate? Because I don't do that right now, and so I know that there are watches, and then just like a Fitbit HR heart rate one. I don't know. Can you do it with your phone?
So you can get heart rate monitors for really cheaply these days. I think you can get them for around $30. That's why I mentioned the conversational pace thing, because I don't want there to be kind of any barriers to people. But I'm sure if you go on Amazon, you can get. I have a higher end one, but I think you could get one for very, very cheap. But it's basically just going slower than you think, right? People think I'm not exercising unless I'm in this, feel like I'm running away from something.
Out of breath. Yeah, that's out
right,
of breath.
Exactly.
Right.
And that might mean walking up hills, and it might mean people passing you that you feel like you should be. So you kind of have to put your ego aside a little bit. But then over time, you start to see these changes where you're going faster and longer. And I don't know, for me, it's where I have a lot of my best thoughts, and I'm kind of looking around at nature, and it's just I really love it.
Okay, cool.
The 180 formula. That sounds great. I like that. So we suddenly lost Dan, but that's okay. We got in everything that he wanted to talk about. We'll have a link to Dan's personal website so you can take a look at all the different projects that he's been working on,
including something called Regional Sodas, which looks to be a collection of very, very locally made sodas.
Yeah, with interesting bottles and labels and stuff. That's pretty cool. All right. Well, thanks, Kevin.
Well, yeah, and thanks to you, Dan. I know that you're listening, and so we really appreciate your being here with Cool Tools.
Thank you.
And Mark, we'll see you next time.
Sounds good, Kevin. Hey, everybody, it's your host, Mark, and I wanted to thank you for listening to the Cool Tools Show. And I also wanted to let you know that we've got a lot more going on at Cool Tools than just this podcast. We also have the Cool Tools website, which has a new tool review every day, and you can get there by going to cool-tools.org. We also have 4 different newsletters that you can subscribe to, and you can subscribe to those from the Cool Tools page. We have this podcast that you're listening to right now. We also have a YouTube channel where we review tools. Check that YouTube channel out by going to youtube.com/cooltools. And one of the things I'd like to ask you is, if you're really enjoying everything that we are producing, go to our Patreon page and support us there. You can sign up and give us as little as $1 a month, and that would mean a lot to us. The money that we get from Patreon goes towards a lot of things. We transcribe our podcast interviews so that you can read them online. We pay for editing of our podcasts and for our videos. We pay our contributors. We have video production costs. We have equipment costs. We have hosting costs. And the money you give us through Patreon also goes to support Cool Tools Lab. Anything you give is a huge help. And one of the things that we do is if you are a contributor to Patreon, we'll give you a shout out on air. And so I have a few people here to thank this week. Mark Lyanaj, Micah Gates, Monty Zukowski, Patrick James McNally, Robert Cohen, Scott, Spence Lloyd, Steve Avery, Steve Golden, Steve Levine, Tom Hess, William Phillips, Aaron Nipper, Durab Patel, Glenn Mercer, Jay Walker, Jeff Bonner, Ryan Jarrell, Pat Daly, Patrick Kennedy, Troy Wallet, Mike Camerate, Nicole Harkin, Tim Youssef, Scott Reed. Thanks all of you for supporting Cool Tools. And if you would like to have a shout out, go over to the Patreon page and sign up. And thanks for listening to the Cool Tools podcast. We'll see you next week.